Hello, welcome to the Energy Sketch. What's that? Someone's missing? Oh, yeah, that's me, Michael Johnson. Welcome. Okay, let's jump over to the whiteboard, folks. And today we're going to talk about the book New York 2140, a piece of climate fiction by Kim Stanley Robinson. Now, in this book, the impacts of catastrophic climate change have begun to manifest themselves. Sea levels have risen by 50 feet. The streets of New York are now canals, and people travel by boat, and they live communally in the upper levels of the skyscrapers that still exist in Manhattan, growing their own food and wine. It's quite a delightful book full of adventure and community. What we'll talk about today is one of the visions he lays out for the future of material production. So today, material production, and that includes cement, steel, and plastics, accounts for about 30% of global CO2 emissions. And I spoke last week briefly about how we could decarbonize plastic production via methanol. And steel also, there is a known route to decarbonize using green hydrogen and the direct reduced iron process. Cement, however, is very challenging to decarbonize. So in the book, new graphene-based composite materials are used because of their extremely high tensile strength and electrical conductivity. And what is graphene? It's a particular arrangement of carbon atoms in a very thin layer. And how do we make graphene? Well, there's a paper linked in the description from 2011, Conversion of Carbon Dioxide to Few-Layer Graphene. And they produce graphene by burning magnesium with dry ice, in other words, CO2, which produces solid carbon and magnesium oxides. And this is the same reaction that I spoke about briefly last week that would allow magnesium to be used as a rocket propellant in the atmosphere of Mars. And there's another paper linked in the description describing concepts related to that. Powdered magnesium carbon dioxide rocket combustion technology for in situ Mars propulsion. So on Mars, it's pretty easy because the atmosphere is made up of 95% CO2. But on Earth, it's quite a bit more challenging, and as we only have 400 ppm of CO2 in the atmosphere. So on Earth, we would need to suck the carbon out of the atmosphere using a technology called direct air capture, and then concentrate that CO2 and then feed it into that reaction with the magnesium to produce our solid carbon and our magnesium oxides. And then the magnesium oxides would need to be recharged back into pure magnesium using renewable electricity. Okay, folks, that's it for this week. Thank you so much for tuning into the Energy Sketch. Don't forget to hit subscribe and hit the bell and all that good stuff. I'd love to hear from you in the comments. See you next week, same time, same channel, Monday, 12 p.m. on youtube.com/@EnergySketch. Thank you so much. Toodaloo!